right, thank you everyone, and thank you for attending. I'm going to start things off with a little known fact. The majority of greenhouse gas emissions in fossil fuels, is it? Are actually released into the atmosphere when the fossil fuels are burned by a consumer. A much smaller fraction of that, 10%, is actually emitted when E&P exploration companies are drilling for oil and gas. A smaller fraction of that on the drilling side of about 3.5%. Is that better? Yes, okay. Very good. So today I'm going to give an overview of the various sources of emissions in land drilling operations, the strides we've taken as Precision to launch a real-time emissions and fuel monitoring system, the things we're doing at the well site to reduce emissions on location, and then kind of the path forward as to how we gravitate towards a net zero future. I'm going to touch on one important point. In order to kind of get to where we need to be, we require a lot of industry and government collaboration. So what I mean here is obviously transitioning to a cleaner future requires an abundance of capital. And as a land drilling contractor, I can tell you we don't have it alone. We also need collaboration with our customers, which are the exploration and production companies. We're actually competing, being such a small portion of the production and kind of upgrading section. We're competing with, megaton projects, both at the E&P level in terms of them deciding what to do from a capital perspective, and then from a government funding perspective. We're kind of a small piece of the pie, so going to need to change that and get some funding in order to move forward. So I'm going to preface this by saying that there's a lot of variability in land drilling emissions. There's different rig types, different engine configurations, depending on lateral length and overall well depth, geographic location, and then on the formation itself. So with that said, kind of on average, a good baseline is from a diesel perspective, utilizing 1.5 million liters of diesel fuel per year. Just in terms of drilling rig power. And that equates to about 4,500 tons of CO2 equivalent per year. So naturally, focus for us is obviously on the actual engine side of the land drilling rig. Now, other sources of emissions, well site lighting, well site equipment like loaders and boilers, support centers, rig moves to and from location, and field support, so transportation of our crews and also support in the field. So before I dive into the various sources of emissions reduction technologies we've deployed in the field, I want to spend a bit of time on what I think is a very integral point. So over the past year, we've had a lot of customers approach us and ask, what is my kind of baseline drilling emissions profile? And legacy methods of calculating this is kind of manual tank dips, fuel receipts, and it's kind of typically done on a pad by pad basis. So not granularity to the engine complex. You don't know what's going to boilers, what's going to loaders, what's going to the drilling rig. And in that perspective, you can't really identify process improvements. So what we've done is developed a system that has positive displacement flow meters to the engine complex. So we're monitoring diesel and natural gas to the engines, boilers, and main tank. So again, engines, boilers will be your kind of primary sources. Main tank, you can kind of figure out what's going to the rest of the ancillary equipment. From there, we layered on power generation KPIs and then regulatory emissions factors depending on where the rig is located. In the US, BC, Alberta, granularity down to the gas analysis, higher heating value, etc. So when we can layer on the power load, available power, generator count, it gives us kind of a snapshot of how we're doing from an efficiency standpoint, diesel liters per minute, and same on the natural gas front. Gives you a sense of your diesel to nat gas ratios and also real-time emissions. So what we've been able to do in aggregating all of this data, we can look by operational classification, whether you're drilling, casing, tripping, et cetera, where the bulk of your emissions are coming from, summarizing it. This is all a real-time dashboard. These are just a couple snapshots. Summarizing it in terms of your emissions per day, breaking it down, CO2, CH4, and N2O. And we're able to see different points in time. For instance, as an example, there are times where you've seen 3 generators online, same power load. If you reduce to 2 generators, it's an instant 13% fuel reduction and subsequent emissions reduction. So this has allowed us to kind of pinpoint areas for improvements and optimization of the engines. Also, from a load perspective, at low load, so same concept, if you've got 3 generators on sharing a low load, the emissions are higher and the fuel consumption is worse as opposed to having 2 generators on at a much higher load. So it's allowed us to provide a baseline, an auditable GHG accounting method, which I'm sure is going to get a little bit more scrutiny in the years to come. And again, kind of the granularity down to the equipment level. All right, now for what we have been doing on the emissions reduction front. So omnidirectional pad walking systems, not new. I'd say from an industry as a whole, we really haven't broadcasted the savings from a fuel and emission standpoint nor an efficiency standpoint. But with these systems, you don't have to rig up, you don't have to rig down for every pad or for every moving from well to well, eliminating a lot of cranes, loaders, trucking. So that's resulted in about 30 to 40% savings from a fuel perspective compared to kind of legacy methods of rig moves. LED crown lighting. So typically on a well site location, you've got 6 to 8 diesel-powered light towers to light up the location. What we're able to do with our 875,000 lumen crown lighting system that goes up there on the top of the mast. So that picture there is comparing those 2 rigs do not have crown lighting, the one that clearly does. Also from a safety perspective, really lights up the well site. So here, again, you're virtually eliminating those diesel power light towers. It uses a minimal amount of fuel and also provides a safe work environment for our crews. Remote support. So we've come a long way. Obviously, the field operations require remote support, whether it's electricians, field techs, et cetera. So what we're able to do now with our PDI, which is what that gentleman is wearing there, is it actually can screen, you see a team screen, and whether it's at the office or remote support center, we can kind of walk through with our crews who are on location already there and not having to go back and forth, especially when you're in remote areas, Northeast BC, Northwest Alberta. It eliminates both the trucking and, again, just makes for a seamless audio and visual communication. Rig automation and smart engine management. So we call it our Alpha suite of technologies. So here you can think of it in its most simplistic form as your cruise control in your car or automated parking feature. So repeatability, reliability eliminates kind of human variance between crews, and we've seen efficiency improvements in the upwards of 20% range. So again, less time on location, less engine runtime hours, reducing emissions. So anything efficiency-wise obviously helps the process. Smart engine management is kind of the automated version of what I was talking about on the slide before, whereby it will know what your power demand is, and it'll kick off a generator if you don't need it, or subsequently ramp one up when power demand is increasing. So with the load profile from a drilling rig goes from 300 kilowatts to 2 megawatts in a flash of a second. So there's a lot to be done from an engine management perspective, and this automates it. We are using that dashboard on the previous slide as kind of a poor man's automation, but we're actually sending notes out to the field to say, hey, we've noticed in the last hour you've had an extra generator on, turn it off. So here we partnered with a customer on with a grant opportunity from Emissions Reduction Alberta. So those that kind of building there, those are 3 natural gas powered generators and then a battery next to it. So typically we have not been able to use just natural gas to power the rig, just again due to that large inrush power requirements. Natural gas isn't strong enough to give that kickstart. With the battery, however, that kind of provides a stable load again, and that allows for straight natural gas usage. In this case, the kind of rig spec prior to this, they were using 2 to 3 generators at all times to drill the wells. With this system, they're finding they can drill most of the well with 1 gen and a battery. So the battery sizes are typically megawatts, 1.5 megawatts, so it effectively eliminates the use of a generator. And again, from an efficiency standpoint, maintains that base load so you can maximize your fuel efficiency and subsequently reduce your emissions. So we'll have 5 additional batteries here deployed in the next couple months, and I think in the next 5 to 10 years, in some way, shape, or form, kind of the new level high-spec rig will have some form of hybrid power on location. And then highline power. It's not new. We ran our first highline power rig in the 1990s, but it's come a long way. There's obviously constraints. You know, you need infrastructure, again, from a utility provider with those random spikes in loads. They don't love it. It's not a consistent use of power. And then if you're, you know, again, in Northeast BC or Northwest Alberta, if the infrastructure is not there, because you're typically demanding about 3 megawatts. But again, depending on where the highline power is sourced from, it is kind of the cleanest form of energy. So where we are today and how we get to net zero. I've talked about the majority of these items, and I'll talk about a couple that we are working on. So with the highline support package, as I said before, it's hard to get kind of approvals and, you know, the peak demand required for a drilling rig. It's hard to have the infrastructure in place from pad to pad to pad to be able to use highline power. So what we're looking at doing now is kind of a support package whereby, you know, maybe one pad you have 500 kilowatts of power available, the next a megawatt available, feeding that in a consistent manner, coupling it with a battery and your existing generator complex. And again, the highline power can charge the battery and subsequently kind of maintain that base load. Hydrogen will play a large role as we gravitate to net zero. So we're currently, you know, exploring technologies that can be applicable to the land drilling sector. Obviously fairly cost prohibitive infrastructure-wise right now, but with what's being talked about, especially in Alberta, and technological advancements, I think we will find a way to utilize hydrogen as a fuel source on a drilling rig. And lastly, well, I guess you guys can't see it, but well site carbon capture. So typically carbon capture projects have been at, you know, the facility level, stagnant, you know, facilities, plants, etc. So we're working on kind of a mobile, modular well site carbon capture that actually captures the exhaust gases and will either transport to, you know, an end user and or utilize for EOR, pumping it downhole and sequestering it. So there's a lot of challenges. We can move from pad to pad or well to well, you know, every couple months, every couple weeks, sometimes every couple days. So there are definitely challenges there, but again, aside from a clean power highline powered rig, it's kind of the only way to end on the hydrogen side, but it's a way to eliminate emissions. Specifically, we've still got, especially in Alberta, in some of our heavy oil operations, we utilize mechanical rigs still. They're still super efficient, they're still pad capable, but you can't incorporate natural gas, you can't incorporate batteries, and you can't really incorporate highline power as they stand today. So it's kind of the only way. So lots on the go, and excited to report back. Thank you.
Great. Thank you very much, Ashley. Yeah, we'll move right on to our second presenter here, is Christian Martens. He's a technical project specialist with Carbon Connect. So Christian graduated from the University of Wyoming, BSc in Petroleum Engineering. He was 2019-2020 president of the University of Wyoming chapter, the American Association of Drilling Engineers, AADE. He holds a diploma in petroleum engineering technology from SAIT. So it's good to be back here at home. And yeah, he has field experience in operations, balancing production targets with environmentally and safety conscious practices. And at Carbon Connect International, Christian is applying his technical background with data management skills to help reduce methane emissions. And he's going to tell us a little bit more about that today. So please welcome Christian Martens. Thank you.
Right, perfect. If everyone could see this. Like everyone said, my name is Christian Martens. I'm happy to be here today for this SP ESG emission reduction event. I'm happy to be back at SAIT. Thanks for hosting this. Also, thanks to the SP Calgary section for having us here, especially you, Ryan. I see your name up there, so thanks for mentioning me and getting me involved in this. Let's get started. So first, my role at CCI, we touched on this already, a technical project specialist. I've been in this role for just about 2 years now, post-graduation. My background is in petroleum engineering, but specifically at Carbon Connect, my job is program management. This is 2 programs that we mainly deal with. The Baseline Reduction Opportunity Assessment Program, BROA for short, as it's known in the industry, as well as the Methane Technology Implementation Program. So between these 2 programs, we directly manage and over hundreds of projects, specifically here in Alberta. And like you mentioned before, my oil and gas background has helped me identify the need for emission reduction at a site level. So at Carbon Connect, we refer to emission quantification as BQI. This is a baseline quantification and implementation. So the first step with any baseline is this is a full-scale emitter inventory. This differs from a production inventory that most people have because this is a full-scale everything that's producing and also not producing. This also involves the measurement and estimation of the emissions at a site level. So with this baseline, we can move to the quantification stage, and this is where we apply cost curves that allow us to compare costs and also prioritize projects. The best way to do this that we found is through MAC curves, which is a marginal abatement cost curve. This is the annual GHG reduction on the x-axis and the cost per ton of GHG reduced on the y-axis. And this spreads it out so you can actually see which projects are the most viable for your company to take, which then flows into the next point, implementation. This involves selecting commercially available technology, specifically the ones that we look at here in Alberta, and it's also creating an investment plan. But the main focus with the implementation is that you have to do post-project verification so that you can actually calculate those emissions that you reduce throughout the project. So looking specifically more at the baseline program, BROA, this was a program that was launched in December 2020 through a $15 million government-funded investment. Its main goal was to help small to medium-sized producers get the full-scale inventory of what they have at site. Since then, it's actually been increased to all producers here in Alberta and midstream companies as well. So right now, we have about 20 service providers who have been pre-qualified to go out to the field and actually collect these measurements. We do the data management and the program management, but they're the people out in the field actually with the measurement devices taking that inventory for us. So in 2021, we had over 11,000 facilities surveyed and about 110 participating producers. In 2022, these numbers have just continued to go up, and the project cost is about $75,000 per project. This is a very rough number. It depends on what the company's needs are, how many facilities they actually want to survey, because obviously a single well battery is going to be a lot cheaper to go to than a gas plant. So, but this is the main purpose of this program was basically to collect a bottom-up emission measurement from all sources on site, not to leave anything out. So transitioning into that, we look at the Reduction Implementation Program, MTIP. This was launched in September 2020, so it came first, kind of the wrong order, but this was a $25 million government-funded investment. In 2021, there was roughly 60 projects as well, and that equated to a lifetime GHG reduction of 10 million tons of carbon. So this is a substantial amount of carbon in 2021, and the average project cost is about $500,000. And much like BROA, this is an inflated cost. We have some projects that are multi-million-dollar projects, and we have some that are low thousands. So this is very dependent on what the needs of the producer are and what they're looking to switch out. And the main purpose of this program here is to utilize commercially available emission reduction technologies. Like I said, here in Alberta, a good example of that is the Methane Emission Leadership Alliance. This basically is a group of service providers here in Alberta that have the technology ready for deployment. It's commercially available, and they're ready to get that technology out into the field to show this immediate emission reduction. It also provides the provincial government with performance metrics required to demonstrate this GHG reduction. And they do that based off the baseline and post-project verification. So just to summarize that again, our year in review for 2021, this was over 11,000 field level emission quantifications, which resulted in 10 million tons of lifetime GHG reduction. So this is a substantial amount, and it happened right here in Alberta over a calendar year. So it's happening right now as we speak. So zooming that in a bit more on the, some focus areas, we have 6 main categories. The first being leak detection. This is your fugitive leaks, your vents that you use OGI cameras to sense, because they're not easy to see when you're out in the field. Pneumatic devices, casing and annulus vents, compressor vents, tank vents. And then the biggest concern is data management. So looking at a few of the specific ones, pneumatic devices, I've listed underneath some specific projects that can come through the MTIP program. These are eligible technologies that we see projects in right away. Device electrification, instrument air conversion, and vent gas capture. This is projects 1A through 1D in our eligible technologies. You also can see tank vents, tank vapor destruction and clean combustor, and tank vapor recovery units. These are 2 big ones that I'll be touching on later here in the presentation. But like I mentioned, data management is a very important subject that we need to talk about, because with all of this new measurements coming in, there needs to be a way to manage all of this massive amounts of data, so that for regulatory purposes right now and in the future, because it's going to be a lot of data. So looking specifically into pneumatic devices, these account for about 15 to 20% of field level emissions, which is quite substantial when you actually look at a full scale of how many pneumatic devices are actually in the field in Alberta right now. So a couple examples: level controllers, pressure controllers, transducers, chemical injection pumps. They all kind of work on the same principle, where they emit natural gas when actuated. So basically what that means, for example, for a level controller, when the level changes in a vessel, they're going to emit some natural gas. So these emissions can either be estimated or directly measured on site. If they're estimated, they can use manufacturer's spec sheets to actually pull emission factors and get the bleed rate that way. Or if they're going to directly measure them on site, they can use OGI cameras or LDAR or a calibrated bag over time to actually get that measurement. But this is actually collecting an inventory of venting as well as non-venting instruments. I think it's important, and CC, I think it's important to know that what you have on site that's venting, as well as what's also not venting, because anything at site is important. This is also an easy target for emission reduction projects. As the regulations just continue to tighten up on pneumatic devices, it's important to get ahead of the curve and get these devices switched over to no bleed or to instrument air before it's too late. I've also included a little screenshot on the right. This is from our BROA data collection app. It just shows some of the key features of what we're looking for when we're actually at a field level inventory, some of the things that we're looking for. So looking at something that's easy to quantify, and now it's something that's hard to quantify: tank vents. They're difficult to measure and to quantify. And this is because that we have to assume that any active hydrocarbon containing tank is venting, unless there's a control in place like a VRU, which is a vapor recovery unit. So when you're looking at a tank vent, the best practice to use is a gas in solution to calculate the emissions. This is actually figuring out how much gas is in the solution and how much that could vent. However, a lot of tanks don't have gas in solution readings available. So if it's unknown, GIS may be estimated using your tank daily flow and the tank pressure drop. So at the bottom there, I included a picture of an LDAR survey of a tank. It's the same tank. On the picture on the left, on the right here, you can see that the tank doesn't look like it's venting. It's just sitting there stagnant. All looks well. But when you actually switch over that LDAR camera to the infrared, you can see that it is venting. But this LDAR camera is just taking a snapshot in time of that vent. So when you actually look at a full-scale vent, this is just a picture. You don't know how long that tank has been venting for, because primarily tank vents when they load or unload. So looking into a couple case studies here. The first case study that we're going to look at is a instrument gas, instrument air conversion case study. This was a smaller project. This included this was about 5 pneumatic instruments changed over to instrument air, switching over from natural gas to compressed air. The annual GHG reductions was 130 tons of carbon per year. So not that substantial of amount, but this is just a small scale project. The estimated useful lifetime of this equipment was 10 years, and that wasn't based on the equipment, that was based on the lifetime of the well that had left. And the project cost was $40,000, so a relatively cheaper project in the grand scheme of things. So looking into abatement costs now, the single year abatement cost per ton of carbon reduced was about $308, which is a larger amount, but this project is small and it's relatively cheap. And there's a lot of pneumatic instruments in the field right now, specifically in Alberta, that can be switched over. So this is a very common project that we see. And if you look at this over a lifetime of that 10 years, that number drops down to about $30 per ton of carbon. So looking at a bit bigger project here, this is a casing gas capture and destruction in a clean combustor case study. So what happened here was the operator noticed a leak coming from their casing, and they wanted to, instead of sending that to a flare, destruction in a clean combustor was what they wanted to do. So this was a pretty substantial leak. So the annual GHG reduction was actually 20,000 tons of carbon per year, which is higher than most. But the estimated useful lifetime of this technology was 20 years. So the project cost for this one was $75,000. So if you take that in terms of your abatement costs, that's a single year abatement cost per ton of carbon of $3.75. And if you take that over the 20-year lifetime, that's 19 cents per ton of carbon. So looking at that in terms of payout in 12 months, your OPEX, that's $3.75. And if you take that in terms of CapEx, that's 19 cents per ton. And this project met both the methods of cost per ton and quantification of CO2. So the slide that I'm going to leave you with here, kind of to wrap things up, it's a little quote from the OGMP, which is the Oil and Gas and Methane Partnership, and they release their best practices and gold standard for producers to ensure quantity and distribution of emissions are accurately quantified. So basically, as I've stated throughout this, the first step to emission reduction with production operations is to accurately quantify your baseline emissions. You need a baseline before you can prioritize any projects. And I like this quote too, because it shows that this has become a global focus. We've been doing this in Alberta here for a couple of years now, and we've been leaders in the industry, but it's good to see that this is becoming a global focus and that the whole world is starting to take notice of that you need a baseline emission to start any projects. So thank you. I look forward to any questions.
Thanks, Christian. I appreciate the presentation. I think that's a good segue here for the next two presenters as well. So next up we'll have David Shackleton talking about some of the work he's doing with IDS, Independent Data Services, which is a Schlumberger company. So they focus on helping operator and drilling contractor clients to reduce their emissions by optimizing their operations through careful planning, measurement, and action. And David also leads the new SBE discussion group on methane emissions measurement, reporting, and abatement, MEMRA. So he's going to discuss a little bit about that as well, which will be coming in SBE Global Technical session. So without further ado, I'll pass things over to David here. Thank you. Thanks, Nick.
All right, good afternoon, everybody. It's good to be here and see some real people. On campus most of the time at Loco Luz, but it's good to be back. So yeah, my background, just very briefly, is physics, mathematics, statistics, and in 9 years, and then more generally with Schlumberger as a bigger. So yeah, thanks to SB Calgary, specifically Ryan and Nick here from Growth and Development Committee and the rest of that team for their work to put this series together. There we go. So a lot of what you've seen from a drilling contractor and a service provider is the importance of measuring, right? Having that baseline. And for me, it always starts with measuring, knowing what you're dealing with. So as a company, as a person here, it's important to know these basics. So I'll just run through this really quickly. This is emissions, think of from the whole industry. Oil and gas industry in 2019. We did a lot of this measurement and calculation there back in 2019 as groundwork for setting our targets to work towards the Paris Accord. So 70% of the emissions that are produced globally are absorbed by the Earth, and only actually 30% go into the atmosphere. We looked into where these emissions were coming from, like these other companies have been doing, just to know what we're talking about, right? And I won't spend much time here, but it's important to know where emissions are coming from on a global scale, right down to individual companies, down to individual rigs, or for you, perhaps human beings. And we've got this issue, let's call it, problem, that the world economy is expected to grow in this time period to 2050. And at the same time, we're expected to reduce greenhouse gas emissions. So it's a difficult challenge. I think you're probably pretty familiar with what greenhouse gases are, and hopefully with the different scopes as well. You know, direct emissions, scope 2, indirect emissions, so from the electricity that you use, for example, scope 2, and then scope 3, indirect emissions 2 from your supply chain, like upstream supply chain, and then downstream as well. So that's like the use of your products as you sell them and so on. And for Schlumberger, as a service company, we do have some scope 1 emissions, some scope 2 emissions, but you can see from this pie chart here, of the 55 million tons of carbon emissions, carbon dioxide equivalent emissions, you can see the big slice of the pie here is the scope 3 emissions. So that's our main area of focus. So just looking at the detail of that, same pie chart, scope 1 and scope 2 are over here, and then our scope 3 emissions are the rest of this column chart here. And looking at the big columns, this one, so this would be scope 3, category 3, our upstream emissions, embedded emissions associated with the goods and services that we buy. So this is like chemicals and minerals that Schlumberger buys, metals and metal components, cement, you know, for example, used in casing of the wells, and then 30% of other stuff. The big elephant in the room, as we saw in the first presentation, is the use of the products, right, and services that we provide, right? So this is where we're focusing most of our attention. It's the use of our products and services that we provide. So what this is looking at the products and services we provide, and we did this, we looked at all of them, and we figured out a basket of about 100 different products and services we have that help our clients reduce their emissions. And these, we bundle them together in what we call our transition technologies, and we're actively promoting them. So with all that background information, we were able to use them to set out our targets. You know, we're looking at reducing our scope 1 and 2 emissions by 50% by the end of this decade. And by the end of this decade, help our clients reduce their emissions basically by 30%. And you can compare that with our competitors here. To be honest, I don't know if this is completely up to date, but most companies will just be focusing on scope 1 and scope 2. You see there's no scope 3 here, for example, and no scope 3 here. But this is really where you want to be looking. So yeah, we cross-check these with the UN Sustainable Development Goals and see that we're involved with quite a few of them, highlighted here. And I'll just go into a little bit about independent data services, what we bring to the picture. So what we've been doing for the past 26 years before we were bought by Schlumberger last year was we had software that generated this. This is a daily drilling report, or more generally, a daily operational report. For the drilling contracts, they would call it a tower sheet. It's a record of what happened at the rig on a particular day. So we've been providing this service for decades, for over 2 decades online. So we went web-based in 2001, which these days is suddenly what people want, which is great. This is why we're busy. In recent years, we've been trying to automate the information, getting the information onto this report in various different ways. One of the most difficult parts of filling in this report, and one of the most time-consuming part of this report, and one of the most useful parts of this report, are the activities, what was done at particular times. So what we've been able to do there is automate that by collecting sensor data from the rig, weight on bit, rotation, ROP, and so on, like 1 second real-time data. We put it through, well, we collect the data, we put it through an algorithm called, we call rig state detection, and lots of different companies do this. Schlumberger developed this back in the day and got the patent, but lots of other companies do this. And then from rig state detection, you get about thousands of states for any one drilling day. The clever thing we do is condense this in a process we call operational state detection. So instead of having 4,000 lines of data, you've just got a human readable chunk of your report with the real activities that happened at the rig. Right? And anything that we couldn't detect with the sensors, like meetings, Johnny cut his finger off, waiting on parts, waiting on weather, these can be added manually into the activities here. And out of all this data processing, we get as a bonus all these drilling performance monitoring charts and dashboards, so you can see the performance of the operation. So this is rig state detection. So this is a 24-hour period, and each of these lines is a key rig state. For example, drilling. You're drilling, and then you're not drilling. You're drilling again. You're not drilling. Rotary drilling. So this one is rotating. So here you're rotating. So you can put these together and say you're drilling rotating. Right? Here you're doing connections. Don't know if you're familiar with the drilling process, but you're doing weight-to-weight connections. Part of that, you're going weight to slip. Here you're in slips. Here your pump is off and you're in slips, and then you go in slips back to weight. So this weight-to-weight connection is something that our clients look at. And you can hear we're circulating. And here in green, we're tripping out. So we're pulling the drill pipe out of the hole after drilling. And then from this, you can draw all kinds of charts and analyze these. So you can see how, say, the night shift was comparing with the day shift. And from this, you can really start to have conversations with people at the rig. You know, why were we getting faster during the night? You know, did you switch the coffee machine on here, or what was happening? And we don't know the answers, but if we present this information to our customers, our clients, then they can have useful conversations to improve performance. So we started working with this national oil company in Latin America back in 2019. And when we started working with them, they had this benchmark KPI target of 15 minutes to complete these weight-to-weight connections, right? And maybe 2 out of their 20-odd rigs would achieve this. But in time, and as we started improving things, their performance started to increase. To going into COVID, this was Q1 2020, just going into COVID, they achieved an average of just slightly over their target. And then once they reached here, they set a new target, right? A lot of our rigs are making this target, so they set a new target, 10 minutes. And post-COVID, as they went back to operating and really looking at the way they did things, they're smashing through the new targets. So from an emissions point of view, you can see that if you're doing things more efficiently, you're wasting less time, you're wasting less energy, your emissions are going down. And this is what we've been working on for a long time. Going much more granular these days, this is a study out of the University of Cambridge, actually our Cambridge research facility, which is largely staffed by people from the university, or studied at the university. This team, for example, are looking at where is the energy being used at the rig, right? You heard about engine use, so you study, how you can optimize your engines, but do you know where most of your energy is going at the rig? And without looking at this, where would you expect most of your energy to be used? Rotating the drill bit, moving the block up and down? Where would you think? So I think this is where a lot of people think the energy is being used to move the block up and down or to rotate the drill string. But you can see here that we've looked at these three major rig systems. The draw works, moving the block up and down, the top drive to rotate the bit, and the mud pumps. And you can see from this very granular chart, so this is time. So this is 6 p.m., 2 minutes past 6, 4 minutes past 6. And this is your CO2 emissions and kilograms per hour. You can see there's a big chunk of red here. So this is the mud pumps. So it turns out that the mud pumps, by far, uses the most energy while you're drilling at the rig. And until you measure that, you wouldn't suspect that probably. So this is the importance of measuring, right? This is your top drive here in yellow. The draw works. Overall, it's very low. You do have these spikes, right, when you're actually using them. So you do have spikes in the draw works that actually refer to, these peak demands of power that you do need. But overall, the big picture, the draw works actually use very little energy. And yeah, the importance of measuring, I can't stress it enough. So for a drilling contractor, you're obsessed by drilling, right? You maybe have a view to pulling out a hole, running in hole. You're looking at the rig move, right? But we spoke literally yesterday to an offshore driller, and we're like, so where do you use most of your energy? And they're like, well, it's the rig move, right? It's not all this millions of liters of diesel they're burning during drilling. It's actually the rig move. This is an offshore driller, right? So a client, they get a contract to say, okay, you want us to move the rig from here to here for your new job. When do you want us to get there? Like, how fast do you want us to go? And 9 times out of 10, they'd say, well, just get there as quickly as possible. So they floor it and they move the rig, right? They've worked out what their optimum speed is, 7.5 knots. But what are the factors affect this? Well, barnacles. It turns out the efficiency of the way they can move is largely determined by the barnacles that build up on the bottom of their drill ships. This is a much smaller boat, but it's the same idea. So, what difference does that make? Have they looked at how many days since they removed their barnacles? They haven't, but they want to. It's a new factor that they're going to look into, so they can see how much energy is used on the rig move, and then they'll be able to know, how much money is it worth spending on barnacle removal or preventing barnacles from building up in the first place. It's a genuine factor, trust me. But yeah, until you measure it, you'll never know. Just to finish off, a quick plug for the SBE and what they're doing. It's a big global movement, 60-odd thousand people. It's down to us to solve these problems. And for young people, I think it's important to stress this, that you're going to be involved with producing petroleum for the next many decades, but also it'll be our job as well to clean up the mess and create these solutions to the climate change problem. So this is what we're looking at in the Sustainable Development Technical Section. There's a global technical section, and their main program where you can interact with them is the Gaia Sustainability Program. So have a look at that if you're interested. What I'm focusing on, being a data person, is this pathway called measuring what matters. We're finding out what matters, what is important, what do we need to measure. And from that discussion, literally, we've come up with a new technical section. It's now just a discussion group, but we're building it into a technical section by the end of this year. Methane emissions measurement, reporting, and abatement. So if you're interested in that, get in touch, and we'll invite you along to the meetings, and you can start looking at what the most cost-effective ways are of doing this, abating emissions, and we'll probably loop you in as well because you've got some good answers too. And yeah, we know Darcy and the other people from your company, so do get involved. SB has a lot of industry partners who've developed these resources too, right? I don't think SB are really looking at inventing anything new. They're going to be using what is already available and finding the most economical, the best, most powerful ways of implementing these strategies. All right. Thank you very much.
Thanks, David. Appreciate it. Yeah, I know we're just coming up on the hour here. With that in mind, we'll go a bit over in terms of this fourth presentation, and we'll have some time for a couple of quick Q&As just from online, and then for whoever's here in person as well, feel free to stick around after, and I'm sure some of our panelists would be happy to chat further as well. So our last presenter today is Devin Lacey. Devin's a senior business analyst at GLJ Limited. GLJ, they're a global energy consulting firm based in Calgary. Devin has 10 years experience in the energy sector, in finance, commercial, project controls advisor, as well on various major upstream and exploration production developments through numerous different projects. Devin joined GLJ in 2020. He's been an integral member of the business development team that's diversifying GLJ beyond traditional oil and gas and into emerging energies and sustainability. He holds a BCom from Memorial University of Newfoundland, an MBA from the University of Calgary, both as a finance major. He also holds a PMP certification. And yeah, Devin has also completed the first Fundamental of Sustainability Accounting, FSAI exam as well, under the Value Reporting Foundation, VRF. So I'm sure he'd be more than happy to chat about that and shed some light on the program as well. Please join me in welcoming Devin Lacey.
Thanks, Nick, and thanks to SAIT and SP for having me today. My discussion is going to be focused around the work we've been doing in what we've called decarbonization pathways, specifically within the Canadian energy industry. Before I begin, I'd like to take a moment to acknowledge the traditional territories of the people of the Treaty 7 region in southern Alberta. The city of Calgary is also home to Métis Nation of Alberta, Region 3. Quick overview of the agenda today. I did want to start by just giving a bit more detail on GLJ, so you have a bit of an idea of who we are, who's presenting here, what our background is, and how we kind of got started with this work. Then wanted to preface the overview of our roadmap process with just an introduction on the energy security within the energy transition and the role that hydrocarbons are going to have to make in securing that. We'll get into the process itself, at least at a high level, just given timing limitations for today. And I just want to finish with a note on Canadian energy and its role within the energy transition in particular. So GLJ is a global energy consulting firm, as Nick had mentioned. We're a team of about 100, mostly engineers, geoscientists, business and data analysts, sustainability professionals. We're based here in Calgary, Alberta, celebrating our 50th year in business here in 2022. We have operated in 60 countries globally, have a wide range of clients on the E&P side, multinational engineering E&P companies, but do a lot of work across the value chain, working with midstreamers, power generation clients, industrial clients, a lot of work with new energy technology startups, doing a lot of technology verification work, and a lot of work with government agencies and financial institutions. Most people in industry know us as a reserves evaluator. That's who we have been for 50 years, but over the last 5 years in particular, we've been putting a lot of focus into diversifying our skill set and helping clients with new questions around new technologies, emerging energy areas, and sustainability strategies. So this is what I wanted to preface with before talking about the roadmaps, and that's the role that hydrocarbons have to play within the global energy transformation. And that role is really centered around maintaining energy security and energy affordability through this transition. That's not to say that renewables and clean technologies are not critically important and have to be deployed at massive scale for us to address the big elephant in the room, which is what Ashley pointed out at the beginning, right, is that 80% of the combustion along the value chain of hydrocarbons is emitted at the end use. But at the same time that we scale that deployment and roll those technologies out, we have to do it in a holistic and balanced way to make sure that energy security and affordability is maintained across the world. And so it's really a result of us being global societies, having formed a dependence on fossil fuels over building our energy systems around those, oil, gas, coal, for the last 150 plus years. So the piece of the puzzle that we see that GLJ can address and that we're doing with these roadmaps is really reducing the emissions that it's going to take to develop the fossil fuels and deploy them, as we kind of recognize the need for them and the dependency on them over the coming decades. It's easy to say that's an industry perspective. It's easy to say it's a Canadian oil and gas industry perspective, but that's kind of what I put up here. It's our dependency on fossil fuels is also considered within the Paris Agreement sustainable development scenarios, where about 50% of our energy supply in 2040 is still going to come from the likes of oil and natural gas. It's represented here in the International Energy Agency's 2020 World Energy Outlook report. There's 2021 report is out now. It tells a similar tale where there's going to be a required increase of about 27% in global energy demand by 2040, largely as a result of growing energy or growing global population and a growing portion of that global population looking to gain access and security and a sense of energy independence, right? So within this IEA scenario, they project a 31% increase in gas, 21% increase in in oil. And our role with these roadmaps is to really help decarbonize the production and delivery of these required fossil fuels over the next coming decades. Again, touching briefly before the roadmap process, this is more of the direct drivers, I would say, that bring clients and organizations to the table to make the investments like we've seen here today from the various companies and to put those wheels in motion, right? So I've divided them here into what I've called voluntary and more involuntary drivers, ESG becoming less and less voluntary and more towards the mandated, with SEC coming out with some new ESG guidance yesterday. But that's beside the point. The reality is that proactive performance on enhancing ESG and sustainability comes with a lot of benefits, right? It advances your risk identification and mitigation strategies. It can improve your access to capital, reduce the cost of capital, improve social license to operate, and it can build long-term resiliency into your business model. It can also give you a bit of a competitive advantage if you have peer groups within your industry that aren't being proactive in this, right? And not achieving these benefits. On the regulatory side, it's carbon pricing, 9 times out of 10, that kind of is looking for mitigation strategies. Clean fuel regulation in Canada for liquid fuels coming in December of this year. Government mandated emissions reduction targets, and on the other side, sort of an increased amount of funding and incentives to go towards these strategies and these new technologies. So the roadmap process itself, the objective of the projects that we do with clients is relatively straightforward. We're looking to develop a viable decarbonization pathway for their assets and operations through the analysis of relevant decarbonization technologies. The current focus of the pathways tends to be on scope 1 and 2 emissions reduction. We do include a lot of strategic conversation about potential scope 3 emissions reduction strategy. I can kind of point out some of those in a few slides' time. But, and the purpose of the project is just kind of to reiterate the objective, right? We're looking to define credible and achievable emissions reduction targets and really put the how behind the targets, which I saw from a few presentations earlier, a lot of focus on showing how the targets have been met and the strategies and investments that are being made. But that's not always the case, right? You hear a lot of net zero by 2050, 30% reduction by 2030. You hear a lot of these targets, but rarely do you see this is the investments and the technologies that we're looking at to do it. And so we wanted to kind of fill that gap with these types of projects. The biggest part of the work that we do with organizations when we start looking at decarbonization roadmaps is a very collaborative workshop where we bring forward our relatively large database of technologies and processes, many of which have been kind of looked at here today. And we start by screening through these technologies with the client. And this is kind of the very high level screening criteria that I summarized for today. It's timing. So is the technology existing? Is it proximal? Is it less mature, more emerging? What's the technology readiness level of that technology or the TRL? Once we kind of bucket the available technologies by when they may be commercially available, we then look at applicability, for lack of a better word. So this is where a lot of operators and service providers have already done a lot of their own homework on this stuff. They know their assets better than we do. They know their facilities better. So a lot, depending on the recovery method, their existing facilities, a lot of technologies, a lot of processes are able to be sort of axed off, and we start to focus in. The last two pieces of criteria, during these workshops, we do discuss them at a relatively high level, but the high-graded technologies that come from this collaborative workshop with the clients, we kind of take away for further investigation. And that's when we look at more detailed techno-economic feasibility analysis or pre-feasibility analysis work. If it's an early stage TRL, we'll look at, what is the reality of the commercial pathway for that technology. And then the impact, which is the most important thing. By impact, we mean what's the materiality of your potential emissions reduction, right? So I took what I could as an example of what the screening tends to look like when it's done. This is an example for an in-situ recovery method. So a lot of combustion-based GHG emissions compared to a lot of the methane leakage and fugitive emissions that we've looked at earlier. So, quite simple. If it's a high grade of 1, these are the technologies that we're going to put further investigation into for the client, and that'll be like high potential solutions for the roadmap. And then, sorry, I'll move on to the next. All right, so high grading these technologies and working collaboratively with clients help us to focus the research, and then it will do summary reports of each of the technologies. Those assessments typically include things like the overall process and functionality of the technology, obviously the decarbonization potential. What is the TRL? And we try to give a very independent opinion of that TRL, not so much the Google search version of it. Do risk and risk mitigation strategies for the potential risks that new technology might come with, and a high-level overview of costs and economic feasibility. As I mentioned earlier, some of the non-technology specific considerations that we include in these reports include impact to your ESG performance. That's easier to do if they're registered with the tier system and have a baseline like what Christian was talking about earlier, or if they are actually doing ESG reports and have that baseline data available. And on the Scope 3 emissions side, we do a lot of discussion on, sticking with the thermal recovery and bitumen example, we do a lot of work with trying to understand potential non-combustion markets, so things like bitumen beyond combustion, and using bitumen for things like asphalt and carbon fiber manufacturing. Other things under the Scope 3 umbrella include product and customer diversification. So if you're going to be investing in new assets, investing in new infrastructure, and now say you're producing hydrogen, what's the potential to scale up that blue hydrogen production for potential commodity use? Or maybe now you're part of an LNG or a CCS value chain, and you can kind of diversify your product offering that way and de-risk. And something we also kind of want to include in the roadmaps is offsets, looking a lot at carbon credit markets, in particular the tier regulated market here in Alberta, doing work with emissions performance credits, emissions offsets credits, and how they can be leveraged to reach these net zero targets or these carbon neutral targets or whatever they may be. Again, apologies for the relatively high level sample. There's only so much I could take, but this is kind of sticking with the thermal recovery example. This is kind of a visual summary that we try to provide alongside reports, and these often find their way into client communications, websites, ESG reports. And so I just kind of overlaid some technologies that we often see within the thermal recovery world, CCS, cogeneration, hydrogen, different deployments of CCS. So maybe CCS on boiler number 1, CCS on facility wide number 1, then moving into CCS of full asset implementation, whether they want to tie into the ACTL, so like a trunk line, or whether they want to support their own infrastructure. These are the kind of details that we'll try to get into. alternate burner fuels, hydrogen blending with natural gas, pure hydrogen if it's going to be available as a scope 2 infrastructure. If the infrastructure is available, they'll take it type of thing, or maybe they want to produce their own. So these get very customized to each client based on their asset base and based on their strategic goals, but this is just kind of a general illustration of what we aim to provide. A final note for me, I just think that there is huge potential for Canadian energy within the global energy transformation, not only in the production of lower emitting hydrocarbons, so hydrocarbons that are produced responsibly with lower emissions to produce and deliver, but also within, we're blessed with a lot of different energy resources here in Canada. We are going to be a player in low carbon fuels, a player in new technologies that we can distribute to the world for use. And I just wanted to leave off with this quote that came out in early March. I thought it was very timely, and it's from the IEA also, so interesting to hear them acknowledge this. It goes that the supply of oil and gas remains vital to stability and security through the transition. As such, there remains an important role for stable, reliable producers such as Canada to supply reliably from their reserves while minimizing emissions. So that's really kind of a summary of our work. Thanks.
Great. Thanks again to Devin, and thanks to our panelists and presenters, and Uwe, and of course Sate for having us as well.